Okay, hello. We're talking, I'm greeting our YouTube visitors. Not you. Hi, everybody. So, today in math class, we're talking about the discriminant, solving the quadratic formula. So far, we just mentioned the discriminant, and we're just talking about it. Tells us how many real solutions we have. So if your discriminant is positive, that means you're going to have two real solutions. So basically, oh, you know what? I want to add a third column to this chart. That's okay. I'll do it in a minute. So positive discriminant, two real solutions. If your discriminant is 0, that means you have one real solution, which actually means, and I'm going to put in parentheses here, that means you got the same number twice. Same answer twice. Because I keep harping on you that you do always get two answers. It's just in this case you'll get two answers that are the same. And then the only other possibility is if your discriminant was a negative number. If the discriminant is negative, there are no real solutions. And I'll put in parentheses again, there will be two imaginary ones. But again, we're kind of leaving those off for your Algebra 2 teacher to go into detail about the imaginary numbers. So for our purposes, if the discriminant comes up negative, we're just going to say that there is no real solution. Now, what does all this mean as far as the graph is concerned? So remember, all of your quadratics, when you graph them, you make a parabola. So if you have two real solutions, what does that mean as far as the graph of the parabola? What would you be looking at? What's happening?
What is that thing saying?
Parabolas. In this scenario, you're going to have a parabola that crosses the x-axis 2 times. Would look something like that. If you were to have one real solution, what's that look like with the parabola? That means that it's still a U shape, but its vertex, the lowest point, or the highest point if you flip it over. Don't worry, just
Get down!
It's fine. He'll retreat. Okay, now. Okay. Okay. Wow. Oh, God. I mean, it's not your fault, but it shouldn't be in here.
I'm allergic.
Christina is. Oh, Vestavia. Get it.
I'll try.
Right? Alright, well, I'm going to edit this from now.
I'm gonna move all of these back.
You're hurting it, you're hurting it.
Got it. That's what she wants to do to stay. I'm not going to
Do what
say
you gotta
that.
do sometimes. Okay.
That's all in the video.
Okay, now we can continue uninterrupted. Phew. Okay, so one real solution. What does this look like as far as the parabola is concerned? The vertex is going to be right on the x-axis. So it really kind of only hits that one time. So that's why you'd only have one solution. And you'll see what that looks like. And then the third possibility, no real solutions. This is when your parabola just never hits it at all. All right, great, Miss Sabia. We understand we're looking for the sign of the discriminant, positive, negative, or zero, but you still haven't told us what it is. Well, I'm about to. You ready? What color should we use for this? Okay. The discriminant is b squared minus 4ac. So you remember quadratics, each one has a, b, and c. So you just take those values, b squared minus 4ac, and see what the answer is that you get out. So let's do an example. Let's say I had, I don't know, how about 2x squared minus 6x plus 5 equals 0. So before I begin, just make sure that your quadratic is in standard form. So if I need to combine any like terms, make sure that it's a, then b, then c, right? A is always the coefficient of the x squared, b is always the coefficient of the x term, and then c is the constant by itself. So just put them in order. If they're out of order, rearrange them, whatever. If something's over on the other side, you move it back here because you want the whole thing to equal 0. Okay? So once it's in there, now I know what A, B, and C are. I actually like to write them down. You don't have to, but I kind of just like to jot them down. What's A in this example? 2. What's B? Negative 6. And then C is 5. So all I have to do is b squared minus 4ac. So b squared is negative 6 squared minus 4 times a, which is 2, times c, which is 5. Sorry. So the only tricky part is making sure that you evaluate this correctly. What is negative 6, the actual number negative 6? If I want to square that, what comes out? Positive 36. And then we're going to multiply these three numbers together. Negative 4 times 2 times 5. Doesn't that get me a negative 40?
No. Yes. Wouldn't it be 80?
No.
No. And then 36 minus 40 is just negative 4. Now, it doesn't really matter what the number is itself, it matters what its sign is. So since the answer to the discriminant is negative 4, how many solutions does this quadratic have?
None.
No real solutions. So this is a perfect example of when the discriminant's going to save you time. You don't now have to bother solving this by completing the square or finish the quadratic formula on it or anything else because there's not going to be any solutions. So why would I keep going? I'm basically done. So if it's negative, then that means this thing has no real solutions. Let's try another one. Say we did something like, I don't know, x squared plus 4x plus 4 equals 0. Well, can't even see it. There we go. So, again, I like to jot down A, B, and C. What would A be? 1, B is, C is 4. So, B squared minus 4AC, let's see what we get. That'd be 4 squared minus 4 times 1 times 4. 16 minus 16. I get 0. You tell me what you get. Did you get it? 0 as well? So, how many solutions does this thing have?
1.
1. 1 real solution. So I know when I go to graph this thing in the next chapter, it's only going to hit the x-axis just that one time. Cool! It's like all these things relate to each other. Go figure! One more. Just for funsies. How about 2x squared minus x plus 1. See what comes out for that. Oh, dang it. I didn't mean for this one to come out this way. Can I change? Go ahead. Never mind. Go for it. Sorry. Everybody's got an answer?
No.
How many solutions does this thing have? No real solutions? Does everybody agree? I think that's correct. B squared minus 4ac. So b is a -1. So -1 squared is now +1. Minus 4 times 2 times 1. 1 minus 8 is a -7. No real solutions. Okay, now how does this all tie in with the quadratic formula and what even is all that? So if you recall real quick, I know I keep writing this, but it's important. To solve quadratics, we are about to have 4 ways. You know 3 of them already. So, if you're going to solve a quadratic, remember, that's you doing the math to figure out where this thing crosses the x-axis. Right? So, the first way we had learned was solve by square rooting. When can you solve by square rooting? It had to be a certain scenario. Do you remember? You're on the right track. It's not a being 1 though. It is one of the variables does have to equal something. It's not a, or I shouldn't, well, you can't have a b term at all. So b's basically got to be 0. So in other words, I don't have an x in my equation, only an x squared. Remember getting the x squared all by itself and then you just take the square root of both sides? That's our easiest one. So again, that one can only be done only if b equals 0. So in other words, no x term or linear term. If I can't do that, what did I try after that? To solve by, yes, factoring. Great. So you're going to make your factors set each factor equal to 0, get your two answers that way, right? Not every quadratic can be factored though, right? So that doesn't mean it doesn't cross the x-axis. It just means that you wouldn't be able to factor it. So if you can't factor it, you can't factor it. What are you going to do? You're going to move on to your third option. Your third option is completing the square. You can do completing the square on any quadratic, but as we learned yesterday, it's a whole lot easier if what is true? What makes completing the square easy? Yes. Not a being 0, but you want a to be 1. Easier if a is 1 and... Why was the homework last night easier than everything we did in class?
They were all the B's were even.
Yes, and B is even. Okay? You can always do completing the square, as we learned, but what a pain in the neck. So, if I don't have a quadratic where A is 1 and B is even, and none of these other things work, my last resort is the quadratic formula. And here it is. Are you ready? So it's just a formula that you do need to memorize, but I'm sure a whole bunch of you know it already. Oh, does anybody know it?
-1/2 square root. Right? No, -2. Nope, negative square root. Alright, then never mind.
You know it?
I think -b squared minus the square root of 4. Is it
You have
something
some of the right parts, yeah.
-b squared plus or minus square root. Something.
There is a B squared in there.
b squared plus the square root of 4 minus ac over 2, or over
You have
a.
some of the right pieces. So here's kind of my point here. The quadratic formula, although it's lovely and it works for every quadratic, it is so common that you don't remember it. I mean, while we're doing this unit, you're going to use it so many times that, yeah, you'll be fine with it in this unit. But what happens when you take a week off from it and now it's the midterm? And you're like, oh, I was so good at it last week. Now, what was it again? Was this a plus or was this a minus? Where was the 2? Your mind goes foggy, right? Imagine for the final. You're not going to be as crisp as you will be this week. However, hopefully, you will kind of just ingrain it in your brain somehow. But that's one of the faults with it, is that you need to know the formula. So anyway, here it is. Please make sure that you write it correctly. X equals -b plus or minus a big old square root, and then under that square root is b squared minus 4ac, and the whole thing is over 2a. That is the quadratic formula. Do you recognize anything about the quadratic formula? Is anything jumping out at you like, hey,
b squared minus 4ac.
isn't b squared minus 4ac just the discriminant that we just talked about? Yeah. So, here's what I like to encourage you to do when you're trying to solve a quadratic by the quadratic formula. Start by finding the discriminant. You're not going to lose any time. You have to do it anyway. So you might as well get the number, because if the discriminant ends up being a negative number, you can stop and you can say there is no solution. I don't have to do anymore. And if there is going to be a solution, great, you already know what number goes under the square root. You didn't lose any time. You get what I'm saying? You have to do b squared minus 4ac anyway. So do it first, see how many answers there's gonna be, and if there's none, move on to the next. If you get 0 or a positive number, I'll show you how to finish from there. Because then all you have to do is pop in this -b in the 2a part. What I need you to do is to look at your equation very carefully. You need to ensure that this fraction bar Goes all the way. It's got to be under this negative b as well as this whole thing. You get what? So, in other words, I want to, don't write this down because this is wrong. If you ever see it written like that, that is not correct. And that's different. That would be negative b, and then you're not dividing the negative b by a 2a. You'd only be dividing this by a 2a. True story, I sew a little bit, not really much. Like, I can, like, make a pillowcase, but I can't do anything super fancy. Well, so one day, I'm in Joann Fabrics, and I'm always looking for math fabrics. They never have them. Lo and behold, there's a math fabric. And I'm like, oh my gosh, and it's got like formulas written all over it. That's how they have the quadratic formula on this math fabric. I'm like, well, I can't buy this bunch of baloney because it's wrong. Oh, really? So anyway, they lost the sale because, and imagine how I'd be ridiculed if as a math teacher I wore math fabric that had the wrong quadratic formula on it. Could you imagine? Yeah.
I got this.
Don't kill Beasley.
What?
I named him Beasley.
Alright, well, I'm gonna kill it now.
Possibly.
Can I?
Yes, just hurry.
I'd like to see it.
Alright, you're touching the end, she's like.
Oh. Just so you know.
Just do it,
You
hurry.
have to pay for it.
Yeah, like he's not strong to hit the window.
No, he's gonna so fail.
No, where'd it go?
Where did it go?
It's on your back.
It's on my back. Wait, is it actually?
No,
Back if it's dead, Ryan.
I'm sure it's gone. Thank you.
Oh, I think it is.
It's dead.
Thanks. Okay, so anyway, let's get this off our screen because it's wrong. So make sure that yours is written correctly. Same thing kind of goes with the square root bar. Make sure your square root is long enough that it covers the entire 4AC, all that. So again, this piece right in here is your discriminant. Mm-hmm. So now let's put all these pieces together. Let's take a quadratic, we're going to solve it, and we're going to see how to play this out. I'm going to start off with a nice one, that the numbers come out really nice. Again, they're not always going to be like that. If they are nice, then you should have factored it. But let's assume, just to learn to have the steps here, we'll do a nice quadratic. How about x squared? Let's throw a negative in here. How about negative 9x minus 10 equals 0. Okay, so if I'm going to solve this thing using the quadratic formula, what's nice is that I don't have to make a, b, 1, or I don't even really care what a, b, and c are because I just pop them in the formula. So if I were you, I would start off by doing the discriminant. Because if it's negative, I get to stop, right? A is 1, B is negative 9, and C is negative 10. So let's do b squared minus 4ac and see what we get. Everybody go ahead and see what your answer is for the discriminant.
So you're gonna get your shot, right?
Yeah.
Just check.
Is this your... No, you had put B.
No, this is my shot.
C is?
Yes.
Oh. I thought you had B. I don't know. I'm all confuddled. If you want to go... Oh, thanks. You're so sweet. Okay. Did you get positive 81 plus 40? Watch your signs, people, right? Negative 4 times 1 times negative 10 would be a positive 40. Just treat this like a negative 4. It gets too confusing if you're trying to do this and then minus it. Just negative 4 times whatever you have in these two. So much easier. So now my discriminant is 121. Is that what you got? So it's positive. That means I'm going to have two solutions. Let's find out what those two solutions are. So now I'm just going to look at the quadratic formula. Let's zoom out so I can get it in there at the same time. So I need to do x equals negative b. So b is negative 9. So is it negative 9, positive 9?
No, it's positive 9.
Positive 9. Plus minus the square root of. You already know what b squared minus 4ac is, right? Because we did it. It's right here, 121. You don't have to do that math over again. All over 2 times a. Since a is just 1, that'd be over 2. Does everybody see where all those pieces came from?
The Segan said there's no line right now, so I'm going to go down, and then if you want, I can come watch your class and you can go.
That'd be great.
You want that?
Yeah, thanks. Does that make sense? Okay. Now, I'm not done. I can finish this, of course. What is the square root of 121? 11. So now I get here, 9 plus minus 11 over 2. Of course, you're not going to stop there. You can do that. 9 plus 11 gets you 20 divided by 2, which is 10. So 10's my first answer. And then I just do 9 minus 11, which is negative 2. And negative 2 divided by 2 is negative 1. And there's my two answers. Does that make sense? Okay, let's try another example. I'm just going to make up, well, you guys make it up. Give me a number from negative 10 to positive 10. 5x squared. Give me another one. Negative 3. Give me another. Plus 7. Okay. So, we have no idea what this quadratic's going to turn out to be. Let's start by finding the discriminant and see if we even have to go any further. Maybe we'll get lucky. Oh, I think we did. Do I have to keep going? No, if I tried to solve this, the discriminant's telling me, hey, it's a negative discriminant. That means there are no real solutions. So I basically get to move on to the next one. I don't have to finish it. Okay, let's try another one. All right, give me a number. Negative 10 to positive 10.
7.
Give me another one.
2.
Give me another one.
Negative
1.
All right, let's try this one. We'll try the same thing. B squared minus 4ac. You all right? Go ahead and figure out what your discriminant is. When I multiply these three things together, is it positive or negative? Positive! Negative 4 times 7 times negative 8 is a positive 224 is what we get. So I get a 228. All right, that means I will have two solutions, so I need to continue. So I'm just going to go to the quadratic formula. Negative b plus minus big old square root b squared minus 4ac all over 2a. It's always helpful to write it out a bunch of times until it's ingrained in your brain. And now I just plug in those pieces. Negative b, so b was 2, so now it's negative 2. plus minus a big old square root. I already know b squared minus 4ac. What is it? 228. So I just pop into 228. All over 2 times a, that would be 14 in this case. So now, ladies and gentlemen, I'm here. 228 is not a perfect square. But doesn't it have some perfect square factors? There's at least one that I know of. 57. What perfect square divides into 228? I mean, these are great guesses, but they are incorrect. 4. And I know 4 is the biggest because when I do 228 divided by 4, I get out 57. 57 does not have any perfect square factors, does it? No. So that means 4 has to be the biggest. So this, I'm going to split up into the square root of 4 times the square root of 57. So how does this come out? Negative 2 plus minus 2 square root 57 all over 14. Are you done? Of course not. So normally you would be, because I can't do negative 2 plus 2 root 57 because they're not like radicals. So I am kind of done in that sense. This, believe it or not, can be reduced though. Huh? Close. Here's the thing though. You have 2 terms on the top. You can only reduce answers like this if the following is true. All 3 of these numbers need to have a common factor. All 3, not just one of them. So it has to be 3 numbers, not in the radical, right? The 3 numbers out in front have to have a common factor, and in this case they do. I can divide everybody by 2. So that means I'm going to get negative 1 plus minus 1 root 57. I don't need to write the 1 in front if I don't want to. All over 7. Whoa, sorry. So that is my final answer. We'll try one more and then I'll have you do them on the board. All right. Let's do one. 9x squared plus, I gotta get this right because I want it to come out a certain way. 9 squared plus 30x plus 25. All right. So, I'm going to start off with my discriminant. Let's see what we get. There will be one real solution, which means when I go to get my answers, I'll get the same answer twice. Did everybody get 0 for the discriminant? Okay, so now when I go to put that in the quadratic formula, again, I'll write it out because it's never a bad idea to just write it a whole bunch of times, getting used to it. Okay, there it is. So now let's see, negative b plus minus the square root of 0. Oh, interesting. All over 2 times a, that's 18. Well, what is the square root of 0? Yeah, so when I do negative 30 plus 0 divided by 18, won't I get the same thing as when I do negative 30 minus 0 over 18? That's how I get the same answer twice. Because I'm just adding 0 and subtracting 0. So yeah, it's going to be the same answer. So basically that just goes away. And I just end up with negative 30 over 18. which is really 15/9. And I got that twice because remember, I added 0 and I subtracted 0. Oh, yeah, I'm sorry. -5/3. Yes. Does that make sense? So that's how you can still get 2 answers, even though there's the 0 there. It's just you got -5/3 2 times. Does that make sense? Everybody's okay? Yeah? All right. Let's try some on the board.